I want to stretch your brain just a little bit here and get you to start thinking about planes as it refers to points and as they refer to lines. When can we define a plane? How many planes can we define? All of these different things I think are really, really helpful for us moving forward. Just again, we're trying to build your visual vocabulary of what a plane could look like. Now, remember a plane, maybe it would help us to write a definition of a plane. A plane is made up of three non-collinear points. Right? That's kind of how we make up a plane, a two-dimensional plane in space. So, example number 1, how many planes could pass through one point? Well, if a plane's made of three non-collinear points, then an infinite number of planes could pass through one point. It's kind of hard to visualize, but if you think about one point, and then maybe we get our parallelogram, right? That could be a plane, right? But also a plane could look like that passes through that point. Or, yeah, it could look like this, right? Rotated, kind of going through that point. Right, all of those planes still go through that point, even if, yeah, and they're all different, right? They're all different. So that is all the planes could pass through one point. It really is an infinite number of planes. Okay, what about 2 points? Well, remember 2 points. A plane is made up of 3 non-collinear points. It's made up of 3 points. So if I had 2 points, well, right, I could have the plane that oops, that kind of contains them horizontally. But I also could have a plane that contains them vertically, right? And I could even have a plane that kind of contains them like diagonally. You can see that, right? I could have a plane that contains them like that. So there's all these different planes and all these different ways that the planes could be going through this number of points. I almost feel like it's helpful to think of it as, well, let's look at our next example as a line, right? Because a line is made up of 2 points. So if we get a line, right, like oops, a line like that. Again, you can have the plane horizontally that contains the line. Oops. Get my tools right, okay. Right, you could have the plane that horizontally contains the line, but then you have an infinite number of planes. This is kind of hard to draw here, but you have an infinite number of planes that they really almost rotate around that line. Oops. So you see, it's kind of, it's almost rotated around that point. Kind of like if you had, if this right here was your line, you have a plane goes here all the way around, right? And that's an infinite number of planes that are going all the way around. You could have put them at any number of points. And that's kind of what I was trying to show with 2 points as well, that you can have this kind of rotating number of planes that are going around. Okay, 3 non-collinear points. Well, right, we said that a plane is defined by 3 non-collinear points. So if we have 3 non-collinear points, the only thing that could contain them would be just one plane. Because, again, by definition, a plane is 3 non-collinear points. Okay, what about an angle? Well, an angle kind of looks like this, right? Have an angle like that. What do you notice about those points that are making up this angle? Hopefully you're saying, oh yeah, they are non-collinear, right? None of these points are on the same line. So again, they could only be contained by one plane because they're non-collinear. Okay, what about 3 collinear points? Well, if we had a line, oops. We had a line, and we had 3 points on that line. Well, it's still a line, so it's just, it's the same thing that happened over here, right? If it's one line, we can have an infinite number of planes that are going around it. We should be writing 1. This is infinite. This is infinite. And this is 1, just so that we're all on the same page. That's a 1. Just a thick 1. Okay. A line and a point not on a line. So here's our point. Here's our line. Well, again, that's the same idea as 3 non-collinear points, right? 2 points are kind of what make up a line. So we have 3 non-collinear points. So again, you've got, just that one plane that can contain all of that. Because if you try to do a plane at a different angle, it wouldn't hit all 3 of those points. Okay, this one's interesting. The intersection of 2 planes. So let's do a plane here. Or if I can make that come out just a little. That's fine. So we've got a plane there. And then we've got another plane intersecting it. Oh, okay. We've got another plane intersecting it horizontally. Just like that. Okay, and then we have a line that connects them. Right there. Right? That's the intersection of 2 planes forms a line. Just kind of like the intersection of 2 lines forms a point, right? So if the intersection of 2 planes is a line, how many planes can go through a line? An infinite number of planes, right? An infinite number of planes. So something I want you to notice here, how many options do we have? We only have 2 options. Either we've got one plane that can go through everything, or we've got an infinite number of planes that go through all this. And that's really, that's a big concept. I would challenge you, if you think that you can find an instance where you could only have 2 planes going through something, I would love to hear about that. I think that would be really interesting. But yeah, hopefully this has helped with your visual vocabulary, helped you understand planes just a little bit more.